equilateral is pretty easy because you know that equilateral triangle, and we'll go back to that notation. So it says if all the angles measures are the same, then we know that all the sides are going to be the same. So we can say segment AB is congruent to segment BC, which is congruent to segment AC. So if this is 12 inches, this is 12 inches, this is 12 inches. And then they go the other way. If it's equilateral because all the angles are the same, then it's equiangular. And that's really what it says up here. If it's equilateral, it's equiangular. If it's equiangular, it's equilateral. So if all of the sides are the same, then angle A is congruent to angle B is congruent to angle C. Now, I think we said this the other day. If all the angles are the same and they add up to 180, what are all the angles going to measure each? 60 degrees. If you divide 3 into 180, you get 60 degrees. So let's go ahead and glue that in, and we'll do an example of that. So number 1, and we're going to call it triangle ABC. We're going to mark all the sides congruent, and they're going to call this side 9x plus 1. They're going to call this side down here 11x minus 23. And we need to find, we're going to have a lot of blanks. We're going to find x. We want to find the length of AB. Now, if you want to know the measure of it, you put AB without a bar over it. So we want to know AB, BC, and AC. We want to know the measure of angle A. And the measure, we already know these. Measure of angle A, measure of angle B, and measure of angle C. So you can go ahead and label those 60 degrees. And then we'll do the algebra side up. Now, if all the sides are the same, you will notice, and it'll look kind of weird because you say, well, they put different things here. But what we're going to find is if all these are the same, then these have got to be equal to each other. If we had one over here, they would all be equal. So we can go under here and put 9x plus 1 equals 11x minus 23. Now, you can move what you want to. It's easier to move the x's first, and most of you like to leave positives, so I'm going to subtract the 9x from both sides. And I get 1 equals 2x minus 23. I'm going to add 23, and again, I go a little bit quick on these, but y'all been doing these since last year. And I get x equals 12. Now, the rest of it is just going to be plugging in like we've done in other lessons. That's a very common algebra in geometry. Now we know x, and if we want to know each one of these, now what's interesting is all of these are the same. So I would take the easiest one in the picture and find it, and then you can just plug them all in. Now to me, 9x plus 1 looks the easiest. I've got 11 times 12. I can do 11 times 12 minus 23 for AC. I can do 9x, 9 times 12 plus 1. It's 108 plus 1, which is 109. Now that's not degrees, that's a side, and I wish they would put inches or centimeters or something like that on it. So the length of BC is 109. So the length of AB has to be 109, and the length of AC has to be 109. In an equilateral triangle, if you know one side, you know all of them. And what's neat is if you put in, here's my calculator, 11, my own screen, yeah, times the 12 minus the 23, it shouldn't surprise you, you're going to get the same thing. So if you put the 12 here, you get 109. If you put the 12 here, you get 109. We don't know this, but we knew all three of them were the same. So once you get one of them, you don't have to do work for the others. Okay, let's write on the isosceles triangle one, and then we'll glue it in. You want to be able to recognize the parts of an isosceles triangle. Well, we know the definition of an isosceles triangle is it has at least 2 congruent sides. Now, they're not always marked sitting up and down, but when it's sitting up and down, the words are a little obvious. The 2 congruent sides are called legs. So this is a leg, and this is a leg. So AB is a leg, and BC is a leg. B is a leg, and segment AC is a leg. The angle where the legs intersect, and to me, I wouldn't have done this the way they said it, but if you see where your legs intersect, in this case it's up here at the top, that's called the vertex angle. Now you can call it angle B or you can call it angle 1. I'm going to call it angle 1. So angle 1, the angle that's between the two legs. The side across or opposite the vertex angle is called the base. Now in this case, it's sitting on its base, but that's not always. We'll draw one in just a minute. This one is the base, and that's side AC. Okay, I did something wrong up here. This was supposed to be AB and BC. Go back there and change that. I wrote leg over here, but I wrote the wrong letter up here. It was AB and BC were the legs. And then these two angles are called the base angles. So this is a base angle. I tell you what, let's do it this way. Let's write under here base angles. And I'm going to point to that one, and I'm going to draw an arrow to that one. And you can call it angle A and B, C, or you can call it angle 2 and angle 3. If you have two sides of a triangle congruent, if two sides are congruent, if you look at your picture, then the angles across from them, or the word opposite they use, the angles across from them are going to be congruent. So angle 2 is going to be congruent to angle 3. Now here's a way we say it a lot of times in geometry. The base angles are congruent in an isosceles triangle. Now they go the other way. If the angles are congruent, so I'm going to draw arrows going both ways. I'm going to draw my arrow going that way, and I'm going to draw my arrow going that way. Then the sides are congruent. So segment AB is going to be congruent to segment BC.